Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is the C++ programming language. Before proceeding, make sure that you have already watched these other videos first. We will be discussing these topics. To watch these videos, look for the links that are listed in this video's description. Computer programming is all about manipulating data and storing data values inside the computer's memory. A variable is a little piece of the computer's memory which we, the programmer, have given a name, like this ix. We can tell the computer to store a particular value, like this value of 1, by writing an assignment statement. A C++ computer program is simply a sequence of those kinds of statements, which the computer will perform one after another. We, the programmer, are kind of like a cookbook author, writing a recipe that the computerized chef will follow, one step at a time, in the order we instructed. See how this same variable can be reassigned multiple times. For a while, that piece of computer memory contained the value of 1, but later we cause it to be changed into 1,000, and then even later, changed again into 11. A computer is made out of electricity. Its memory actually is nothing but a bunch of ones and zeros because of electricity being turned on or off. For a number like 11 to be stored in computer memory, we need to combine several of the ones and zeros into some form that represents a number like 11. There are several ways this representation could be done. So, before we use any variable, we need to specify which method of representation we want to use. This is called defining the variable's type. A very convenient C++ type is called int. This is good for representing many integers like 11. Our computer program can manipulate multiple variables. We can do basic manipulations on them, like applying math operations or comparing two data values. Notice that the equal sign is written once in an assignment statement, but it is written twice in a relational expression that tests equality. A definition of a variable and an assignment of a variable can be combined together into a definition that uses an initializer. This standard cout stuff is just another kind of statement. This one prints some output text onto the console window. Usually, wherever you have a single statement like this one, you could instead have written a whole block of statements inside braces. Every statement block creates a new scope, which just means that this is a new place within which we can define and use variables. This local scope can define a new variable with a new name like iz. Inside the local scope, we can still use those other variables, like ix, that had been defined in the outer scope. By the way, this outermost scope is called the global scope. Here inside the local scope, we can also define a new variable that reuses a name of one of those outer scoped variables. Here I'm creating another iy variable, which hides the original iy. Both variables still exist in computer memory, but here I only have access to the locally scoped one. Every variable has a lifetime that ends at the end of its scope. So when the computer gets to the end of this local scope, this iy's lifetime is over. That value of 2000 gets discarded. Afterwards, we are back in the global scope again. Our source code that uses iy now has access to the original iy variable, which still has the same value of 22 that it has had all along. For everything that we've seen so far, the computer will run our program by executing our statements one after another in a straight line sequence that flows from the first statement to the last. But we could cause that program flow to jump around if we want. we could take some of the statements and move them elsewhere into something called a function. Functions have a name. This one is named do computation. Where those statements used to be, we use that name to write a function call. Now, when the computer runs this program, its program flow will start in a straight line from the beginning of our sequence, but when it gets to this function call, program flow will magically jump up to the body, up to the inside part of our function. After finishing doing those statements, the program flow will magically return back to where it left off. The great part about functions is that they can be reused as many times as we want. We simply write the function call again and again anywhere we want to use it, and a running program will do those statements each time, without us needing to have typed them more than once. Even our main sequence of statements should actually be written inside of a function. Every C++ program needs to have exactly one function named main. This tells the computer where to start. When we run our software, the computer will start at the beginning of main's body. A C++ programmer uses a tool called an editor to write code like this into a file called his source file. A C++ source file usually has a file name that ends with .cpp. Then the programmer uses another tool called a compiler to translate his source file into an executable file. It is that executable file which he sells to his customers. His customers can run that executable file on their computers to do whatever that software has been created to do. The examples we do in most of our videos are kept really small to stay simple to describe. So usually you will only see one source file in our videos. But in real-world situations, software gets very complex and big. So to be manageable, a real software project will need to split up its source code into multiple source files. A compiler actually first compiles each source file into an associated object file, and then another tool called a linker is the one that actually combines those object file pieces into the executable file. This whole entire process is called building your software. And there are several different companies, like Microsoft, who sell this combination of editor, compiler, and linker tools for C++. When we split up our source code into multiple source files, it often happens that there's some portion of our code that we would like to write the same way in more than one file. It's not a good idea to repeat ourselves by just repeatedly typing that same code over and over again. That's too much work and it's hard to keep consistent. Instead, we put that reused code into another file called a header file and only leave a marker at the place where we would have typed all of it. In this example, iostream is the file name of the header file. When the compiler is doing its compiling work, the first thing that it does is to do a pre-processing step, which recognizes this include directive and then acts as if we had actually typed all of that header file stuff right there at that location. In our videos, we will sometimes show an example of what it might look like if you were to use software engineering tools to build and then run the example code. Real-world software often interacts with its users through graphical interfaces, but to keep our examples simple, we will usually demonstrate output being written into a console window, as you see here on the right. A function can exchange information with the code that calls it. One reason we might want to pass information into a function is that it allows us to parameterize the function. For example, it would be silly for us to write both a add12 and a add1112 function. They both are just doing the same thing. They both just add. Instead, write one function that accepts parameters. In this case, the two parameters are the two numbers that should be added. A function is not required to return any information back to the place that called it. In that case, we say that the function's return type is void. If the function does want to return some information, say for example, the sum of these two numbers, then specify the return type before the function name and specify the returned value in a return statement anywhere inside the function body. A function could have multiple return statements. C++ is an object-oriented language. In addition to primitive types like int, a C++ programmer is able to define his own custom types. Now, a variable can store more than just one simple value. This is now an object variable. It's kind of like a master variable, which is a structured combination of individual variable pieces. This dot notation is used to access those individual pieces, which are called its data members. In C++, a programmer's custom type must be defined before it can be used. Such a definition is called a class. A class definition lists what data members exist. When that class name is later used to define an object variable, we say that it is being instantiated. That newly constructed object variable will have enough computer memory set aside for a new instance of each of these data members. Object orientation encourages us to organize our software nicely by encapsulating data members together within a class definition, along with some functions that are written specifically for manipulating those data members. These are called the class's member functions, and they are also listed in the class definition. Given an object variable, the same dot notation is also used to call one of its member functions. We have additional videos describing details about C++ objects and dozens of other topics. Links to those videos are listed in this video's description.